Oh no. Okay, let's see. Oh, did Jeff bring, this is what we're working on today. This is also what we're working on today. I think I might have some. No. So if you did not get a copy, I'm gonna have to print you one out from my office. Yeah, I think they're all over there. Okay. Potentially. Yes, okay. So if we look at this, at the very least, if you didn't get the blank copy, you can cover these with a piece of paper, kind of try them on your own. So I mean, the way I did this first problem, if you're allowed to use a number on the very inside, I would first thing just figure out what that number is supposed to be inside. So if I can know what g of 2 is, I could just plug that directly into f. That's the idea. So this is f of g of 2. If only I knew what g of 2 was, I could plug that number in. All right, let me just take a minute and figure out what g of 2 is. Yeah. Same thing I did on part B. And then part C, I couldn't do that. I'm like, damn it, Jeff. So then you have to actually take f and shove it into g. And this one you got to be careful about because you have to distribute that negative. Okay. How do you guys feel about this? How do you guys feel about the finding the inverse process? Have you formulated an opinion or no? You're like, jury's still out. It's good? Okay. All right. This should be really nice, I would hope. Because all you got to do is figure out the points and turn them around. Okay. And this one, at least one person showed me they got this. The whole purpose of H inverse is to kill H. And you can think of it vice versa. The whole purpose of H is to kill H inverse. They're kind of like antimatter. So when they come into contact, they annihilate. Right. No bright flash of light, though. That would be neat. Everybody's doing the work and bright flashes of light are just going off. Yeah. You have found your wand. Okay. So what we're going to do today is we're going to get into linear functions. So I want to ask you guys, let me see. Oh, before we do that, what do you guys think about, I was trying to remind myself, let me see, let's do this. Let's all travel down this road together. We'll leave behind my bathroom tiles. That's great. Let me see. I love these little announcements in Canvas, and they'll have the little box that says, don't show this again. But it just keeps showing it to you no matter. Okay, sorry. Our first test is on the 17th. Oh, that's right. This won't let me open the calendar. I love that. Okay. Calendar. Hey, look at me spell. Okay. I don't care. Just give me a calendar. Give it to me. Let me see it. Okay. Where are we at? August, September. So our first test is on the 17th. We are currently here. Yeah. The 3rd. That's it, Jeff. So we got 1, 2, 3, 4. And then the 16th is going to be review day. Did I remember that correctly? Is it the 17th? Yes. 16th is going to be review day. So probably the 10th, I would give the practice test out just so you have more time to look at it. And on the 15th, I'm sorry, the 16th, I would have the answer keys. Everybody with me? That's how tests are going to run. I'm going to give you the practice test at a time. The class before the test will be devoted to review. And I'll have the answer to the practice test, the answer key to the practice test. Which means, where'd it go? Here we go. We need to be done lecturing on stuff by the 15th. So we don't need to have a quiz on Tuesday, but the further back I push our next quiz, the more stuff will be on it. You guys kind of with me? So there's a bit of a give and take there. So if I put it on Wednesday the 3rd, I'm sorry, Wednesday the 10th. That would be really mean. If I put it on Wednesday the 3rd, you guys have free reign to kick me in the shins. If I put it on Wednesday the 10th, I'm okay with having this on it. If I push it back anymore, I'm going to put more sections on it. You with me? So what do you guys think? You think a week from today for the next quiz? Yeah? I think so too. And of course I kind of led you there, but it's okay.
Also, we don't really like this idea.
Not really, but I like to make it have a veneer of democracy. So we're like, you know, anyway. Sort of like where we are. Okay. So let's do that. So officially, a week from today, we'll have our second quiz. It's going to cover the rest of chapter 3. This was behavior of graphs, like finding the local max and min, the increasing, decreasing. Oh crap, this was what we did last time, the composition of functions. Well, we just went over the f of g of x, that kind of stuff. This was finding the inverse. Graphing it, finding it algebraically. Horizontal line test, yes? So that'll be on that quiz next Wednesday. That should give you plenty of time to finish that homework and have questions from it answered. Okay. So what I want to do tonight is I want to first ask you guys what you remember about lines. Can anyone tell me anything they remember that goes with the mathematical usage of lines? Do you guys remember anything about lines? The function, what parts there are to the line?
Like an origin or
Huh?
something?
Say again?
An origin?
Origin, kick ass. So, I'm very wide open when I say, so we have to have sort of like the idea of somewhere that lines could live when I graph them, right? And that was this. Does anyone know what this is called? This, of course, is the origin. Because when you try to find points, you start there. And you count over, up, down, left, right. Okay.
Is it like the Latin thing?
Oh, I like that. No. So it's either, it's called the XY plane. You guys with me? Does anyone know another name for this, by the way? So if I put something on there, it's called the graph of the function? Sure. Okay, so there are a few admittedly boring urban legends in mathematics. One of them is, there's this guy named Descartes. Rene Descartes, and he did a ton of stuff. Too much. It's like leave stuff for somebody else. Supposedly he was sick in his bed, staring at the ceiling, watching a fly meander around his ceiling. You with me? Just laying there in the daylight. I really hope the fly doesn't like land on me. So he's watching the fly, and he realizes I could track the movement of the fly by his left and right motion and his kind of like up and down motion along the ceiling. You with me? So he's the one that came up with this idea of how to plot points and so forth. And of course we borrowed it to do latitude, longitude, and laid it on the surface of this Earth. Yes? So we call the official name for this is the Cartesian coordinate system, named after Rene Descartes. So this is we'll just call it XY plane for the most part, but it's also called the Cartesian coordinate system. And of course it's a plane, because how many dimensions does it have? 2, and how long does it go for? Right, good. So you can say that that wall here is part of a plane that extends up and down forever. Okay. So I got all of that from when you said origin. I got on the side, I'm like, perfect. That's a bit of it. Now tell me anything else about lines. What else do you guys know? What parts of a line are there? What do you have to figure out to graph a line, to get the equation of a line?
Slope.
Slope is huge. Slope is huge. Okay. Well, oh, cool. Okay, guys. So we'll even make it intercepts. Y-intercept is kick-ass. What letter do we associate with the slope?
M.
Of course M. Why not M? There's no M in the word slope, so we're like M. So there's the legend, the theory about that is that it's related to the French word for walk, marche. So that's why we gave it an M. I think it's just somebody made that shit up. Anyway. So slope, we give it the letter M. Y-intercept. X and Y. What did we call the Y-intercept? What letter does that get?
B.
B. So is all this coming back? Or maybe you knew this and you just weren't sure what the hell I wanted from you when I asked you, tell me anything. I literally meant anything. Yeah. And then if you put this together, what is the most compact kind of form for the equation of a line? If you, yes, good. Yes, y equals mx plus b. Okay. So all that stuff coming back, do you guys know all that? Remember some of this stuff? Okay. So let me ask you this. How do I find the slope of a line? What do I need? I need 2 points, at least. Can somebody remind me what the idea of slope is?
Rise over run.
Kick-ass. So in English, rise over run. If I recall good old XY plane, when I rise, which variable is changing? Y. And what kicks ass is it rhymes. That's crazy. So what I normally say is rise over run is Y's over the other one. So rise is Y's, difference in the Y's. Run is X's, difference in the X's. So that leads to a very kind of famous little equation. If I give you 2 points, how do you find the slope?
The change. Y2 minus Y.
Yes.
Over X2 minus X1.
Kick ass. There's a lot of misunderstanding about subscripts, right? Superscripts normally are, in mathematics, are going to be exponents. Subscript just means, if you see a little number on a variable, that means it's just a specific value of that variable. So in this case, I have the second y minus the first y, and the second x minus the first x. Now, why do we have the dumb things? Because if you do one in the wrong order, your slope will be the opposite side of what it's supposed to be. Yes? That's the only freaking reason we did that shit. We're like, if you pick this y and that y, you better pick this x and this x. You have to go the same way. Okay. What does it mean if a slope is positive?
Mine's
Going up? Going down. Okay. So let's do this. What if I gave you these 2 points? What do you got, Jeff? I don't know. Let's do this one. Sure. Can you find the slope between those 2 points? Oh, that's in the way. Okay. If you really want to be fully explanatory, you can call this one x1, y1. You don't have to do this. And then you just directly substitute, right? So 2 minus 4 over 5. Now here's where people trip up. What mistake did I make? Yeah, there's a minus in the equation, and there's a negative value for one of the points. Yeah, okay. So then I should get negative 2 over 6, negative 1/3. If you do it the other way, 4 minus 2, sorry. Is that right?
Yeah.
Okay. If I do it the other way, 4 minus 2 for the y's, I have to do negative 1 minus 5, and I still get negative 1/3. It doesn't matter.
So it's when you flip flop of from that is
Yeah. So that's why it's got to be whatever. It doesn't matter which point you call the second point. Who cares? But as long as you keep the direction the same. Yeah. Okay. And this is why I wanted to start with this, because I know you guys have talked about lines before. I just need to kind of like dredge it back up out of your memory. Okay. What does it mean for a slope to be 0? Good. It's a flat line like this. And what kicks ass about slope is it's one of the most immediately applicable physical ideas. So has anyone ever gone hiking or even mountain climbing or bouldering or anything? Okay, so if you go to like an indoor rock climbing place, right? You've got, sometimes when you have bouldering, they have all these different angles of things. My favorite one, I don't even, is the one where you have to kind of go back and, no. I mean, it's my favorite one to just stand and watch you go. You guys have this. I'll just go up this and the normal. So slope equals 0 is hopefully what this building is experiencing right now, the floor. Yes? If it isn't, then we gotta get some help. With me? We got people come in with the little surveying tools, and later this semester we'll actually learn the math behind the surveying tools. If the slope is positive but small, that could be like a ramp going up somewhere. Yes? You want to have a gentle slope. If the slope is big positive, then that's going to be like climbing a freaking mountain. Yes? So it's immediately physical, which doesn't happen a lot with mathematics. So slope in math is the same thing as slope in real life. That's crazy. So this would mean the line is flat. Of course, what would it mean for slope to be undefined? Yeah. Does anyone ever talk about slope being undefined? Do you use a different word for it? Yes, infinite. Because if I ask you, so here I am, like this would be 1 hour, 2 hours, 3 hours. This is where I am. I'm on the couch, yes? You with me? And it's great. This would be 1 hour, 2 hours, excuse me? This line has an infinite slope because how quickly does everything change? Infinitely quick. This is like, this is 0 because how much did my position change over time? None. Here, this is instantaneous change. Not only that, I don't want to get too freaky. This is like I exist everywhere at once. Because at 2 seconds, I'm not here. At 3 seconds, I am everywhere. And at 4 seconds, you're like, do you guys see that? All right, let me stop. You guys with me? I'm pushing a little bit, but has anyone ever heard straight up and down lines having infinite slope? Yes, okay. So, and of course we were talking about positive, negative. Beautiful. So let's do this. Let me bring some structure back here. So in our module 2, if you happen to ever take, does anyone have any plans to take statistics at some point? Right now? Sweet. I'm going to have to ask you later when you do linear correlation. You're going to be doing this kind of thing, but you're going to be calculating the line that best fits the data. Real quick, just out of curiosity. Do you guys see what I just did? Doesn't that make sense? If you had to draw a line that best fits the data, do you think you could do that? Like, this is obviously wrong, right? So the line that best fits the data would be the line that averages where the points are. Do you see what I mean? So you're going to talk later in your semester, you're going to talk about how to get that line to best fit exactly right. Not by hand, thank God. That's a little much. But we could all kind of give a quick sketch of a line there, right? So in real life, there aren't a ton of things that are perfectly linear, right? There just aren't. You always get a little bit of variability. But there are certain data sets that are closer to linear than something else. Energy usage is normally kind of like oscillatory, like this. We need more energy in the summer, and then less in the spring, and then more in the winter, and then less in the fall. Yeah. So it kind of goes like this. Okay. Blah, 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 blah. Okay. So let's look at this. Stay with me. Please don't do that. No, you're fine. No, you can do it. It's fine. I'm just worried I'm going to fall out. So real quick, can you guys plot those points? We haven't talked about this directly yet, but try to plot those points. Thinking I wanted to take, I didn't have time to make it actually spell a word. And I don't know. Oh, well, you got to do something. All right. So let's see. In general, even if your points had different letters, like C, D, whatever, it's always alphabetical order. So this is the origin point. How do I find this point? It tells me to go 2 streets back and then 3 streets up. Fire. Oh, fire. I thought you said liar. I'm like, that's weird. You lie. And then you can't handle the truth. 3, -1. So then I would move over 3 streets down 1 street. Bam. Okay, that's amazing. Now, we talked already about the algebraic way to figure out the slope. Y2 minus y1, x minus 1. How do you find the slope just visually? What's the slope between those 2 points?
Negative 4.
It is negative. Be more specific. Yeah, because you told me, the very first thing you told me, I think it was you, slope, the idea of slope is rise over run. So if I start at either point, which point do you want, the higher or lower?
Higher.
So if I start here, how much do I rise? I actually do what? I actually fall, so I'm going to negative rise. So my rise over run is going to be -1, 2, 3, 4. And my run is going to be how much? 1, 2, 3, 4, 5. Shabo! Okay, so if I give you a graph, getting the slope is quicker, because then it's just counting over, up, down, whatever. Yes? Why does it make sense our slope came out negative? It's going down. So if this is my profit, I am sad. Yes? So I can kind of draw the line. It didn't ask to draw the line in, right? But we could. I'm just going to do it because I can do whatever I want to. So it's a little check in the middle of a problem. Make sure that if you think the slope's negative, your graph is actually going the correct way. Because if not, you did one or the other one. So example 2 is nothing really too crazy, but example 3 is a little more interesting. Slightly. Stay with me. 3, -2, and -4, -2. So of course, if you count it out, if I start at either point, by the way, I'm sorry. Yeah, this will be, I go up or down 0, and I go over, it doesn't matter. Yeah, 0 divided by who cares? As long as it's not 0, right? 1, 2, 3, 4, 5, 6, 7.
Can you write who cares?
No.
Is that 0 over who cares?
Oh yeah, I was about to, but I could. This one, okay, wait. Up here. We started there, we went here. What if I start here? What do? I go up, so I rise 4, yes? And then I go back 5. Now, real quick, math sees those 2 as the same thing, yes? We see these as 2 different things when they're slope, 2 different directions as to how to move. So if I got a path I'm on, if I do one way, I go over here. If I go the other way, I go over there. I'm still on the same linear path, but I just end up in 2 different places. Okay. Which makes sense, because if I can go from this to there, I have to be able to go back. Okay. We'll see how that comes into play later. I'll bring this back up. If I remember, let's find out. So here's where things get a little bit interesting. Let me see if you guys can stay with me for a second. So you guys know this equation, yes? Do you guys know the other equation? Oh no! Was that one too? Oh, okay. If you turn the page, you know. So real quick, go with me. Remind me what the formula is for slope by itself. Now, real quick, this is saying that if I have a line and if I pick 2 points, I can find the slope. Do I have to pick, if somebody starts off like at x1, y1, do I have to pick a certain point to get the slope right? If I have a straight line, does it matter what other point I pick? No. The subscript means it's a specific point. So that's like if I'm given 2 points. You guys just agree with me that the slope will not change because it's a stupid straight line. And if the slope changed, it would curve. Yes? So if slope does not change, it doesn't matter what that second point is. It could be any freaking point on the line, except of course for that one. So I'm going to rewrite this as, now that, I don't know how you guys feel about it. All I did was take the subscript off. But what does that mean? It means,
It could be like x3, y3, or x4.
it could be, yeah, it's not tied to be any specific other point. It could be any other freaking point. So on one level, this seems kind of silly, but it is. Now, how do I solve for my y stuff? How do I get the y stuff by itself? Yeah, multiply by the stuff I don't want anymore. Poor little guys. So then I get y minus y1, yes? Equals m times x minus x1. So that, of course, is the point slope form that we all love, including Damien. He loves it very much. He's stuck in it, throwing it on. So here's the difference. And here's where they're the same. Let me see if you guys can go with me. This means slope is here, y-intercept is here. This means slope is here, and any other point. So this one I can use directly if I know the y-intercept. This one I can use directly if I know any other point. Okay. When you get to calculus, there is a way to use this one almost all the time. This becomes very important in calculus. I try to get my students in the beginning of the class to just use this most. Maria can maybe attest to this. This relates to linear approximation. So it relates to something early in calculus, and then it relates to something in Calc 2 from there, in case that's in anybody's future. Okay. So let's figure this out. We haven't talked about the intercepts directly, which is one big difference between these two. So let me do this. Let me talk about the intercepts directly. Very quickly. So if I had a line or another line or whatever, what is always true about where it hits the y-axis? What's always true there? X is 0. I don't want to move left and right at all. I only want to move up and down. So if I'm given a function, if I'm given the actual like y equals 2x minus 7, if I want to know what the y-intercept is, I would make x 0. So if I set x to 0, I'm going to force it to tell me the y-intercept. So of course, how do I find the x-intercept? Set y to 0. So if I set y to 0, I force it to tell me the x-intercept. All right. I think I made the case pretty well that I'm a weird person. But I always think about like this. I have this equation under the bright light, and I'm like, tell me where you hit the y-axis. So if I set x to 0, I'm forcing it to give me information. And if I set y to 0, I'm forcing it to give me this information. Okay. So real quick, if I look back up here, if I do set x equal to 0, what do I get? Y equals b. So that's, of course, why that's the y-intercept. Why is it the y-intercept? Because it's the number that's left when I make x 0. Okay. If I look at this one again, let's say, so help me out real quick. What point did we just create up here in this problem? What was the input?
0.
What was the output? B. So let's say this is going through the point 0b. Where do I put 0? Specifically, which x? x1, good, because the subscript mean it comes from a specific point. So this would be y minus equals x minus, so I'm going to put 0 here, yes? What do I put here? B. So y minus b equals m times x, and then I add the b, and I get the same equation, yes? So one equation, this equation, becomes that equation if I know the y-intercept. I know it's crazy. Thank you for playing along. Okay. Now, again, this is pretty basic stuff. Some of you guys are like, okay. But some of us have forgotten this stuff. Yes? Okay. So here is the point slope form written by a calculator, so a computer, so maybe you can read it. They give a quick rundown as to where it comes from, sort of. So let me do this problem a little differently. Can you guys plot this point? We can't, because this, oh man, this is what I get for trying to do this in a different way. 2, -3, is everybody with me?
Yep.
Okay. The slope is -4, so this is one reason why I want to do this. Slope is -4. Is everybody cool with that being over 1? Yeah, because slope is rise over 1. If I have a whole number slope, I can always put it over 1 so I know what the hell's going on. If I try to go down 4 from where I am, I'm going to subtract, yes? Yeah, exactly. It's like the way I bowl. The other guy's like,
Yeah.
sorry. I thought you joined your. Sorry. Oh, thanks. I'm amazed I come up with something like that. So mathematically, math will kind of say what the shit's wrong with you if we just put the negative. It's like, all right, if you want to, human, it's still freaking -4, but that completely changes the idea of what's happening physically. What would this mean? Go up 4, back 1. Okay. Kick ass. So if I go up 4, 1, 2, 3, 4, and I go back 1, there I am. Up 4, 1, 2, 3, 4, back 1. Okay, so I purposely, good Lord. I need more or less of this. That's better. What is the y-intercept here? Be more specific. I think somebody said it. 0, 5, cool. Okay. So I am a math teacher, so I get to be an asshole. So intercepts are points. You should say, you're doing a great job, Jeff. Intercepts are points. So if I say, what is the y-intercept, and you say 5 or something, I'm going to be like, no, try again. So it's a point. So you have to tell me 0, 5. Now help me out. Can you guys, if I call this x1, y1, and this is obviously m, can you guys do this formula for me? Can you guys build this? Go ahead. Let me say it this way. Build that formula for me using what we know. The real question is, why did you sign up for this class?
You hate me.
I want somebody to hate me. Let me sign up for this. I need some hate in my life. So we know the y value, we know the x value. You gotta be careful because the y value is negative, right? There's a minus in the equation and a negative on the number. So help me, guys. The way to look at this equation is y minus the y piece. What's the y piece of the point? What's the y piece of the point? -3. Equals m times x minus the x piece. Now, can you solve that for y? Basically put it into mx plus b form. Some of you guys probably already did, because it's kind of like ingrained in you if you do it at all. It's just a standard procedure. If you haven't solved for y yet, do it. And I don't just mean subtract 3, I mean distribute like terms. Solve for y. So minus -3 is plus 3. Distribute the -4. And then I just subtract 3. And what did we recover? What is this? Yeah, that's the y-intercept. Kick ass. So it's got to kind of come together. So if I graph it one way and I find the y-intercept, the algebra better come out the same way. If you plug a 0, you get 5. Kicks ass. Okay. So all I need to graph a line is a place to start, a point, and a direction. The slope. If somebody gives me a place to start and a direction, I can carve out a path from there. Blah, 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 blah. All right. So, and then I get into mx plus b. Now, without saying anything, can you do the first part of equation 6? Example 6, sorry. Find the equation of that line. As long as you know. So all I want you to do is find the equation, right? So if I want to use this equation, I need to know what m is. What's m? -5. And I need to know what b is. What's b? -2. Good. So b is the y value of the y-intercept. The y-intercept is always a point. And then I just got to plug this stuff in. So y equals mx plus b. Yes. So let me ask you this. I'm going to change this problem because I want to. See this stuff? Screw it. I want you. If you already did it, it's too bad. Stop overachieving. I want you to figure out the slope. Let me think about this for a second. The slope and should I make this? Yeah, I should make this there. Yeah, there we go. I want you to figure out the slope and the y-intercept.
Got it, easy.
Oh, yeah, I made it negative. I just changed my mind. Sorry. So just do that for me. Now listen. That was easy. We just did this, right? If I gave you this equation, can you tell me what the slope is? What is it? 2. What's the y-intercept? 0, -7. I gave you this equation. I want to know the same information. Why is this equation harder? Why was this equation easy? What form is this in? y equals mx plus b. Is this in that form? Okay. So now you know your first step. If you put it in the right form, the information you need just pops out. This is a really cool general rule. We're eventually going to get to a point where we might look at equations of circles. And if you write the equation of a circle in a certain form, the center pops out and the radius pops out, because that's the two most important things to know about a circle. X squared plus y squared equals radius squared. It's just a good old Greek dude, right? Pythagorean theorem. So I'm not sure how you guys are trying to do this. Do you guys all know what you're trying to do?
Yes.
So I'm trying to get it in this form, which means I'm trying to solve for y. So what's in the wrong place here? Yeah, these dumb x's. So I want to get them out of here. And of course, the last thing I need to do is divide by negative 5.
Yes.
And of course I get. So this is a smart way to do it. Don't just put it underneath everything. Put it under each thing, so then you can reduce each thing easier. So what's the slope? 4/5. And the y-intercept? Kick ass. All right, go ahead and graph that line. So now you know where it begins, you know the y-intercept, and you know the slope. Oh, well, if that was true, my job would be a lot less interesting. This is like Jeff Goldblum says, students find a way. So let's see, y-intercept 0, -2, so I know where I'm starting, and then I go from there how? Up 4, 1, 2, 3, 4, over 5, 1, 2, 3, 4, 5. Shaboom. What point is this? 5, 2, and what must be true about that point? It's a really weird question to ask. I don't care. What must be true about that point? Every point this line goes through, what must be true about it? You can do it. What do you think? It better work in this equation. Can you guys take a second to make sure 5, 2 works in this equation? You guys see my question? I want to know, I want you to show me that the point 5, 2 works in this equation. Trust me, bro, it's not good enough.
Source, trust me, bro. What was the question? Oh, plug in?
So listen, I see exactly what you're talking about. I don't know what you're talking about, but I see it. What were you talking about?
Not for real.
I want you to show me that the point 5, 2 works in that equation.
It checks out.
It checks out? How'd you check it?
I plug it in and
How do you mean plug it in?
so like 5 is the x value.
Good.
2
5 is
the y
x,
value.
2 is the y value.
Yeah, and it's 20 minus 10, and then you get
Kick ass. So, let me do something I'm really surprised I forgot, because this is one of my favorite things. Can you guys give me one answer to that equation? That can't be an answer to this equation, because how many unknowns are in this?
2.
So in order to give me an answer, you have to give me 2 values. So 2 2's. So I'll accept it as an x equal y equal, or a point, because that means x equal y. So 2 2's. Give me another one. 3 1's. Give me another one. 1 3. Give me another one. 6. 6 -2. Watch out. Now we got to the negatives. Kick ass. Now we got the fractions. He's up to 4 plus the square root of 11 and negative square root of 11.
Alright. Yeah.
Now, real quick. If I ask you, give me a complete list of all the answers to that equation, what would that mean? How long would that take?
Eternity.
Eternity, exactly, because one answer is 40, yes? Another answer is 3.9.1. Another answer is 3.99.01. Another answer is 3.9. I mean, I could just get stuck there forever. You with me?
Yeah.
So there's sort of an infinite number of infinite infinities that answer this question.
Oh.
So, if somebody said, give me all the answers, we graph the damn thing, and we say, there you go. So a graph is the quickest way to say, these are all the solutions to this linear equation, yes? That is the most fundamental reason why we might graph something. Now, of course, a bigger reason is because if I graph something, it very often interprets into physically what does this thing look like as it moves. So we think about trajectories. Throw a ball, looks like a parabola. Unless the wind's really heavy, and then maybe it looks like that or something, you know. You guys kind of with me? So graphing gives me a physical interpretation of what's going on, but most fundamentally, it's just what are all the answers to this? Okay. That's a quick little aside I like to talk about. That is why I do anything. All right. Oh, we don't want to do that yet. So let's do this. Here, I'm going to give you this. You're not going to believe it. I have a handout.
Yes. More handouts.
You make sure we're able. Ooh, 7 might be an issue, but we'll see what you guys think. Oh yeah, thank you.
You saying we don't like a challenge, Jeff?
Say it.
Are you saying that we don't like a challenge?
No, I said it might be a challenge.
I would have said we said be as soon as I go very quiet. I think.
Oh, if I said that, then you should. I'm sorry. Oh yeah, don't do the colorful Griffin
Dude, that's
side.
easy, dude.
Do the boring ass.
You said do it first. Wow.
Do the one that's what is it? Portrait, not landscape.
Can I do this side actually?
Let's find out. Do this side here.
Oh. Ooh. I like it.
Now, did anyone read the title?
The legal and mathematical.
Thank you.
Oh, I like the legal ones.
No, do it.
Do the legal lines. What do you think?
What'd you do in math class today?
I did some lines, Mom. Hey, Mom, I did some lines today.
So happy.
With my teacher.
Yes, exactly. Teacher shares.
Oh,
Teacher shares.
all right.
And at any point, if you need help, you can call me Maria, or you can work with people near you. It's fine.
Hi, Maria. With this guy?
Huh? Well, why don't you sit there?
Literally, my guy here first.
Exactly. Oh, man.
All right.
I just talked about Dragon Ball in my earlier class.
Alright, see, I
I can teach like graphing inequalities. You know, it's trouble like which way does the person go? Do this and then I'm shooting them like that. So
I thought these two were related, so I was looking.
oh
at this
yeah,
one.
I got you.
So I was like,
Yeah, it's a totally separate problem. Yeah.
That's right.
there's no line. You're just plotting points. So that was just making sure I forgot to do something. Somebody's okay with the fact that number one does not make a line? Yes, if it does. That's an issue. Manage to make a line out of that. Make many of
I
them.
plugged in zeros for each one to get the intercept. I think it was set for the right form first.
You said you're half.
Handle. On number one.
Oh, that's funny.
On number one.
On one?
Or number two.
Number two.
Sorry, number two. Anyways, I just realized.
Now should we find the intercept, right? So put like 0 in for y to get the x-intercept, right?
Oh, I see. So you don't actually have to solve for any letters. How do you find the
Or
x
should I
intercept
get
and
the
make y?
another equation first and plug that into 0? Like
So
when
you actually
this one x
work
is 0,
directly
it's a
with
y
the
intercept,
way it
and
came.
vice versa.
Because that'll ask you for the slope, you don't have to put it in. You can start plugging zeros in, right?
Okay.
And then.
You see what I mean? You're not doing wrong. I mean, can you tell me what the y intercept is? No, can you tell me what the x intercept is?
That's what I got, yeah, so do that, I got y to
Nope.
negative 1. Get rid of x and whatever.
You lucked out. I could have made this slope something so you don't get the other.
Well, I don't know. It's divided by 3.
In general, you plug a zero in for x and the y intercept.
I think I feel an accident. I think it's supposed to be
So
divided
you
by 3x.
don't have to do any of this.
You get
no.
4x.
If all I want are intercepts.
I don't know what I did. I'm just trying everything.
Okay.
So easy. Yeah. So first I divided by 3
Divided by three.
from both sides.
So you're gonna divide everything by three?
I guess I have to, huh? I guess I did that wrong.
Cause it wouldn't get rid of the x.
Yeah.
You would just remove it.
And go away and we're not zero. So what point?
Cause you know,
X is zero. Y is zero. So that point is
y
zero.
to by itself on one side.
Okay.
Careful.
I think so.
So I see what you're doing.
Yeah.
This one
Alright, so what do I
would be 4 0.
So then you would do just like negative 4y equals negative 3 to get y by itself.
Be careful because these are 10, 20, 30, 40.
Okay.
So it goes down.
Just replug in 0 for one points, so you get.
We're not done isolating.
3 goes down 3.
And then you divide by 4.
Oh, yeah.
I see. So then y equals
But each step you take this way is 10, yes?
3 over 4x.
Now watch out for the C.
Minus 3.
Okay.
So this is the equation
Oh,
for
I
the
see.
line.
I'm with you. It
From
goes
here,
down.
so I plug in 0.
Yeah.
Or no.
Yeah, I mean.
Or you could plug that and then just find them.
You can find the y-intercept by plugging in x for zero here.
No, it is. I know. I'm
Well,
saying
what's
you
that?
lucked out
Sorry.
that the slope happened to
We can
get
find
you
the
back in the
y-intercept by
x-axis.
plugging in x for zero.
It doesn't have to always
Yes.
do that. I could have made the slope take you up here.
You
You know what I mean? So you wouldn't have been able to find the x. You got lucky that this top brought you there. You know, I'm just trying to tell you in general, you can't always do it.
Well, yeah.
Yeah.
Okay.
And then you could
Do the same thing for this one, 0 and 1. So that one? Okay. I erase this.
And then you could even just graph it from there.
Yeah. Thank you.
So let's see. That's if one is negative 6, and then 6 minus 6 is 0. And that is undefined. And this one is greater 9 over 1. Yeah. You're good. I'm not sure what.
Yeah.
Because this one didn't, this one, if you graphed it, it would be
Yes.
6, 1, 6, negative 5, so it's got an infinite slope, yeah. Yeah, you're fine.
Okay.
And I will try for
This one? Oh, it's minus 1, and then I switch the. Yeah.
Yeah.
Oh, it's just my, I keep switching the numbers. There we go, okay.
There you go.
I need you to use your second sense.
What? Oh, no, you're right.
Okay. we were talking about if I do hit the axis, right, the y-axis, then x is 6, right? Because it didn't move left or right. So x is 6. If I do x-axis, then y is 0. They go up and down. Right is, so y is 0. If you leave x 0,
No,
the
I'm
y answer you get
curious.
is the y
You
value.
can be curious after you finish your worksheet.
I just got put a thing.
So minus -3. What's negative 4 as far as I come? And what's minus negative? Good. So negative 2 plus 9. So negative 9 plus 4. And this, or you can't just stop here. What does that mean? Undefined. Or you could say infinite, but undefined is the more general way that we refer to it. Wow, that's crazy. Yeah, I don't want to do this yet. Yeah. No, why? Gotcha.
I forgot what the word was. Very nice. Okay, so good.
Oh, it's perfect. All right, so now, continuing my ask foolish ways, I'm going to force you into little groups so you can kind of check in with each other. Can you guys work together? Can you like turn?
Yes.
Can you work with that up there? And can you work? Yes. Can you go back and work?
No.
Howard team.
No.
All right, look,
I sing too much of it.
go up there, work that. You guys,
Alright.
is that good? You work with you guys? Oh, who's here? Like a little bit. Oh, yeah, you totally cheated. But no, you didn't cheat, because that is the y-intercept. So once you get the slope, that is the y-intercept. Well, that looks right. 9 over. You went that. See what you did? You went there to there, but then you went there to there. So go up here and
Okay,
when you get
one by one on this side.
Basically, for me, I just think of it as getting y by itself. And so, first you gotta get this x.
Pass. One really great thing about being a teacher is if I want to leave early, I can. So we're going to do this. I'm not going to leave right now. We're going to do this worksheet, and then we're going to call class. And if you guys have questions, they'll still stick around. But I'm going to end class a little early. Why? Because I want to. Yes, feel free anytime, Jeff. I don't think anybody should have had trouble with this.
Unless you're a chronic overthinker.
Oh, I see. Okay. You'll do yourself in if you're a chronic overthinker. So, guys, please, dear God, if you have a problem like this, please, dear God, label your points. Yeah? So, -1, 3, put a frickin' A next to it. Because can you imagine somebody gives me this thing with just freckles on this graph, and I'm like, I don't know what's going on. 0, 2 is B. -3, -5 is pew, pew, C, and then D is -4, 0. Okay. So it makes a little constellation. Okay. Slope of the line containing the points. So you could do it multiple ways, but my point is this: if you choose to do 5 minus -4, so you're going this way, you must do -3 minus -2. And everybody I came around and saw, you all managed to do the bottom, okay? It can get a little tricky with multiple negatives, but this would be 9 over -3 plus 2, so it'd be 9 over -1, so it's -9. And come to think of it, I think most of you guys did -4 minus 5. You still got -9. Kick ass. This one could get a little trippy, but difference in the y's divided by difference in the x's. I always get somebody try to tell me that's 0. Did we talk about why that's undefined? Do you guys know why that's undefined?
Yes, we spoke about it.
We spoke about this?
Yeah.
Okay.
Indeed, we did.
I will not speak about it again. Okay.
Sorry.
Okay. Huh? So now this one, here's one of the last math courses I took. I had an equation that had about 13 variables in it. I had to find the w-intercept. What did I do? I made every other letter 0. My point with the story is, I don't give a shit how far you go in math. To find the intercept of one variable, you make all the other variables 0. So there are mathematics where you have like 30 dimensions. You have 30 directions of motion. Yes? So if you want to find the whatever intercept, you just make all the other letters 0. What's kick-ass for us is we got 2 letters. Yay! So if I want to find the y-intercept, I make x 0. So when I do that, I get y is -3. Now I'm going to make a mistake here in a minute on purpose. I like to call out my... Every now and then I'll say that just to cover my ass in case I make a mistake. If I make y 0, I get 3x is 12, and I get x is 4. So then, of course, that means I go through the point 4, -3. Now what's wrong with that? That's a mistake. I'll get somebody plot 4, -3, and then they'll put a question mark. And again, a few of you guys I saw did that. Don't take it. If you did it, that's understandable. It's totally understandable. Why wouldn't you do that? X is 4, y is -3, Jeff. What the shit? But how did I get -3 for y? I made x 0. So 0x goes with -3y. 4x goes with 0y. So that point does not necessarily exist on this line. Okay. In fact, it can't. So then I put 4, 0, and 0, -3. And then I get this dude. Yay! Okay. Fantabulous. Now, slope for the following situation. One thing I noticed was a few of you guys weren't noticing this is in tens down here. 10, 20, 30. So, and a few of you guys were doing y2 minus y1, which, while it isn't wrong, it's more than you need. And I sort of don't want to see that. So if I give you the visual, all you have to do is, I'll go down from this point to this point. I'll go down 3. And then I go over 10, 20, 30. So -1/10.
Yes.
Can you interpret that for me? What does -1/10 mean in the physical context of the problem? Because I want units, right? So what is -1/10? That's the numerical answer. What should the units be?
Every 10 minutes.
Okay, every 10 minutes, because that's this. The candle burns down 1 inch. So it's -1/10 inches per minute. So in 10 minutes, how much of the candle will it burn down? 1 inch, because it's 1 inch per 10 minutes, right? Kick ass. So units on slope is really silly easy. Whatever the unit is on the y, whatever the unit is on the x, you just make a ratio out of them. Yeah.
Since it, like, you can see it cross, like, every 10 minutes, can I just assume?
Oh, I see. Like if you take a smaller step.
Yeah.
Yeah. Okay. That's so beautiful. I'm gonna cry a little bit. So that's a big step and it reduced. But do you guys see if you go down 1, you go over 10,
Mm-hmm.
and that just gets you there quicker. Some of you guys did this and this. If you go down 10, you go over 100, it still freaking reduces to this, yes? Okay, you kick ass. Okay. So a bunch of little small steps make a big ass step. Yes? Okay. Life lesson, kids. Graph the line that passes the point. Okay, this one's not too bad because I give you a place to start and a way to go. That's all we need. So -1, -4, and then from there we're going to go up. 3. Over 1. Okay. And of course, I sometimes get somebody, what do you guys think is the big mistake I see?
Oh, they're gonna just graph.
Huh?
I didn't have to find a freaking equation.
No, it just says graph the
Oh,
line.
my fault.
I don't believe it.
The equation too.
Jeff, why did you make the instructions so bad? Oh, no.
Everyone are used to being abused by their math teachers. That
I know,
were just a
I know,
simple problem.
I know.
It's like-
Yeah. I'm sorry, guys. So if you go, what was I saying? The biggest mistake I see is somebody looks at 3 and doesn't realize it's over 1. So they just go up 3, make a dot, and then do a straight up and down line, which is a little insane, yes? Because that would mean slope of what?
Undefined.
Undefined, yeah. Or infinite, yeah. Whee! No equation. Oh, by the way, this is how I write equation. EQN.
Why?
That's interesting.
Because it's a quick way to write equation,
Is
and
that a U?
that's an
I thought that
N.
was a U.
Yeah, sorry.
I don't like that.
Even then, by the way, even then is bad, but the less I write, the better it is for everybody. So that is just a quick way to write equation. Function, I can do like that.
Fun.
Can you just do EQ period?
No.
Why not?
This is ingrained in my head. I don't even think about it, so I have to explain it.
What does it mean? Like the under.
Equation.
So why is it?
Why is that?
This is the power of N or something.
So, several of my instructors at the college I went to, that's the local thing they developed. So every class I took, I saw that.
Why'd you underline the N?
Sort of like how I
It's
write
not a real thing.
my 7, like this.
So I think we're getting a
Oh, that
little
makes
lost in the
sense.
weeds here.
I don't care. Okay. So, if I ever write equation, you know what I mean. EQN.
I'm not required to write it that way though, right?
No.
No, okay, thank you.
Alright, so doing this one. If I want to know the slope and the y-intercept. So up here, I just want to know the intercepts. There's no reason to solve for y. In fact, that kind of is backwards, to be honest. You with me? If I want the intercepts, don't solve for y. Just plug zeros in. If I want the slope in the y-intercept, I might as well solve for y, right? So to solve this for y, subtract x, and then divide by 3, and the best way to do this is to put it underneath. There's a little bit of concern sometimes here. I can just make this. Is that cool? So then I can see m clearly. So what's the slope?
-1/3.
That's crazy. And what's the y-intercept? No.
Excuse me, 0, 4.
Thank you.
Pardon.
0, 4? 1 over 3. And then I had an interesting discussion at one of the tables. Math would chuckle at us putting the negative underneath. It's like whatever you want to do, human, with your time. But that means something entirely different physically, right? If I start here, this would tell me to go up 1, back 3, and I still stay on the same dumb line, because of course if I can get from one point to the other, I better be able to go back. You guys kind of with me? And that does come in handy every now and again. It's just good to remember that you're allowed to do that. This dude, why is this guy better than this guy?
Because you're given the line.
Yeah, you're given the y-intercept. So whenever the first dude is 0, I know the second piece is b. So all I need is m. All I need is m. So then how do I do that? I'm not even sure what song that was from. I don't know. Yeah, y2 minus y1. I think everybody did it the opposite way I did it, but that's okay. So you get -9/7, and you kind of take a moment, you go, that's gross, and then you're cool with it because you just have to put m in it and b in there. Okay. So everybody doing okay? I mean, okay. And then finally, this guy, the slope was, I think, -1, yes? Which way did you go, Jeff? Which way did you go? -1. And so if I do y minus the y piece, equals m times x minus, good Lord, Jeff, the x piece, there we go, y plus 2 equals negative x plus 3, y equals negative x plus 1. Now, a quick way to check, which point did I use to create this? 3, negative 2. If I plug negative 4 in, what should I get out? 5. So negative 4 is 4 plus 1 is 5. Yay, so you can check your work pretty easy. Just use the point you didn't use. If you use this point, it's going to be true no matter what, because that's how you built the damn thing. But use this point to really make sure everything came together right. Okay. Yes?
You said for quiz makeups, if you have like a 90 and up, you can get 4.
No, 95. Because if you have an 80 or above, you could get 5 points back max up to 100. So if you got a 95, you can get up to 100.
Okay.
A lot.
Today.
Huh?
Can I turn them today?
Hell yeah, I've already got people turn them in. I didn't grade them yet, but I will. So guys, that's it. We're done. If anybody wants to hang out, if you got questions, feel free.
Alright, see you next week.
Get out of here, Damien.